Humanity has always wanted to explore the unknown, to journey beyond the confines of our own planet in the immensity of space. The iconic Voyager 1 spacecraft has made an unexpected discovery as it just made contact with a highly advanced object in space. Can this discovery change our whole understanding of human existence on Earth? Prepare to go on a journey of discovery that will revolutionize all we thought we understood. The Voyager missions have been at the forefront of space exploration for over half a century, giving priceless insight into the secrets of our solar system. Given the volume of information obtained, it's difficult to think that these missions were not planned to run this long. The origins of the Voyager program are a fascinating story. Michael Minovich made a discovery when he realized that a spaceship may use the gravity of a planet to slingshot further into space. This resulted in the 1977 launch of Voyager 1 and Voyager 2, with the goal of researching Jupiter and Saturn. What happened next was nothing short of miraculous. Voyager 1 spacecraft has made contact with a highly advanced object in space. Both Voyagers have 3.7-meter radio dishes and 16 thrusters to let them alter their orientation and point their dishes towards Earth. Their engines run on hydrazine fuel, and their electronic components are powered by thermoelectric generators driven by plutonium. Both Voyager 1 and 2 are equipped with 11 scientific equipment, half of which were supposed to research planets but have since been deactivated. Imagine embarking on an epic voyage to explore the undiscovered depths of our solar system, accompanied by 2 dependable spacecraft. Your first mission is to investigate the massive Jupiter and Saturn. That's so cool, right? And boy, did those probes deliver. They sent back never-before-seen photographs and data, drastically changing our knowledge of these gas giants and the famous ringed planet. While Voyager 1 said goodbye to our solar system and headed into interstellar space, Voyager 2 had some intriguing stops in store. In 1981, a correction maneuver was performed to direct Voyager 2 towards Uranus. The spacecraft ultimately arrived at the isolated ice giant in January 1986, after surpassing its initial estimated lifetime twice. But it was only the start. Voyager 2 discovered 10 previously undiscovered moons on its journey to Uranus, adding to the burgeoning cosmic family. But the ultimate destination was Neptune, where Voyager 2 took almost 9,000 photos and discovered 9 previously unknown moons. The 2 spacecraft have spent the last decade exploring the vast and enigmatic interstellar medium, the area between stars populated with scant stuff. And they're still finding new things. The intensity and direction of the interstellar magnetic field, which has caused heated dispute among scientists concerning the form and activity of the Sun's magnetic domain, the heliosphere, is one of the most astonishing discoveries. After Voyager 2, no other spacecraft has returned to Uranus and Neptune. From afar, scientists have been able to see and analyze extraordinary events on these worlds. The list of ice giants in our solar system is rather limited, with only 2 members like Uranus and Neptune. Despite the name, the bulk of the material of these planets is not frozen, but rather consists of hot supercritical fluids composed of volatile chemical components like water, ammonia, and methane. It is a state of matter that combines liquid and gas qualities. Did you know that Uranus is the second most distant planet in our solar system, with an average solar distance of 1.8 billion miles, and its diameter is more than 4 times that of Earth? Uranus takes around 84 years to orbit the Sun, and during that period it appears to be laying on its side. The cause of this unusual axis tilt is unknown, although astronomers believe it was caused by a collision with a huge protoplanet early on. This might also explain Uranus's 27 moons, which may have developed from the crashed debris. If that isn't enough to pique your interest, a large white splotch on Uranus's surface has been identified. Because of these iconic probes, we have access to all of this information. When NASA's Voyager 2 spacecraft visited Neptune in 1989, it recorded several unusual weather events, including brilliant bands of clouds in the atmosphere and storms reaching high speeds of up to 1,305 miles per hour, the fastest winds ever witnessed on any celestial world. Experts believe that the absence of solar energy reaching Neptune permits these storms to whip up to such amazing speeds, but they might vanish one day. Scientists spotted the Great Dark Spot during the Voyager 2 mission, a gigantic structure the size of Eurasia that was thought to be a hole in the planet's apparent cloud cover. However, when scientists tried to discover the location again a few years later, it was no longer there. The heliosphere is a huge area of space impacted by the solar wind of the Sun. It is the area where the Sun's influence extends and interacts with the interstellar medium. It resembles a large, bubble-like area of space. The heliosphere, which was previously assumed to be shaped like a comet, may really be more spherical. What happens to the heliosphere when sunspots develop and then vanish? The spacecraft has revealed some surprising information. When the solar wind, a flow of charged particles emitted by the Sun, comes to a standstill, the interstellar medium begins. This ionized gas or plasma acts like a boulder in a river, pushing up against the colder, denser plasma that surrounds it. The hole formed by the Sun is known as the heliosphere, and its edge is known as the heliopause, similar to how the top of Earth's troposphere is known as the tropopause. Sunspots are black, planet-sized areas that occur on the Sun's surface. The sunspots grow and wane over an 11-year period, causing the solar wind to increase and diminish, pushing harder and then less on the heliopause, but with a 2.5-year delay. As a result, the heliosphere expands and contracts. The heliosphere should have been substantially smaller during Voyager 1's passage than it was during Voyager 2's, since the pressure from the solar wind was lower in 2012. The relatively identical distances, on the other hand, show that the heliopause is more durable than previously imagined. Even though the actual shape of the heliosphere is unknown, Voyager 1 and Voyager 2 continue to drift away from it. Voyager 1 will be 155 astronomical units from the Sun by the end of this year, and signals from the spacecraft will take more than 22 hours to reach us since they travel at the speed of light. Voyager 2 will be 129 astronomical units away when it passes the quiet Pioneer 10 in late 2023, becoming the second farthest spacecraft ever. These two spacecraft are traveling in opposing directions, and they are currently further apart than either is from Earth. Furthermore, in the middle of May of last year, the Voyager 1 onboard system known as the Attitude Articulation and Control System, or AACS, which is in charge of keeping the spacecraft's high-gain antenna pointed at Earth, began beaming home confusing jumbles of data instead of the usual reports about the spacecraft's health and status. From our vantage point, the spaceship looked to have developed a disease similar to electronic aphasia, which inhibits one's ability to communicate fluently. It is conceivable that the data was created at random or does not reflect any plausible condition at all. NASA said at the time in a statement that the AACS could be in. Even more perplexing for the engineers was the fact that, despite the strange status updates from the spacecraft, Voyager 1 looked to be in fine condition. The radio signal from the ship is still strong and consistent, suggesting that the antenna is still pointed at Earth and is not in the configuration stated to NASA by the AACS. Similarly, even though the AACS was experiencing the strangeness, the science systems on Voyager 1 continue to acquire and send data as usual. Furthermore, whatever went wrong with the AACS did not trigger a fault prevention mechanism, which is supposed to put the spaceship into safe mode if a problem occurs. Fortunately, NASA specialists were able to detect the problem and provide a remedy. The AACS had started transmitting telemetry data via an onboard computer that had stopped operating many years previously. Because the dead computer damaged all of the outgoing data, all NASA engineers had to do was direct the AACS to utilize the right computer to send its data home. The next stage is to determine what motivated the AACS to switch systems in the first place. According to NASA, the system most likely got an erroneous order from another onboard computer. While they say that there is no immediate danger to Voyager 1's safety, the underlying reason must be found and addressed to minimize further damage. Subscribe to our channel for more videos and information related to the Voyager probes. Voyager 1 has been a real pioneer in the immense expanse of interstellar space, traveling outside the protective protection of our Sun's magnetic field for nearly a decade. The environment is hostile, with high-energy particles and cosmic radiation hitting the vessel from all sides. Despite these obstacles, Voyager 1 has continued to advance, providing crucial data and insights into the secrets of deep space. Strange incidents, such as the latest AACS breakdown, are par for the course in this unprecedented mission, according to Susan Dodd, project manager for Voyager 1 and 2. After 45 years of exploration, the Voyagers continue to be a testimony to human ingenuity. But did you know what the James Webb Telescope discovered that shocked the entire world? Watch this video on your screen right now to find out more.